Euclid's Elements, Book 1, Proposition 16. In a triangle, if one of the sides be produced, the exterior angle it creates will be greater than either of the opposite or interior angles. So let's have a triangle, ABC, and let's produce BC to D. I'm going to prove that this exterior angle is greater than either of these two opposite interior angles. So this exterior angle is going to be greater than the angle at A. We can also prove that this exterior angle is going to be greater than the angle at B. So this is what we're going to prove. That angle ACD is greater than the angle at A and greater than the angle at B. Proving the universal truth that an exterior angle is always greater than either of the opposite interior angles. So let's label these. Let's call this angle here our exterior angle, angle 1. Let's call this angle 2, angle 3, angle 4. So we're going to prove that angle 1 is greater than either 2 or 3. The first thing we're going to do is we're going to bisect AC into two equal portions, and we know we can do that. Because of Prop 10 allows us to bisect a given straight line. So we're going to make A, let's say we'll make this E. We'll make AE equal to EC. And we're going to, then we can connect B and E. We can do that because we can, postulate 1 allows us to connect any 2 points. And then using postulate 2, we can extend BE out here to say G. And from this greater line, we can cut off a portion equal to a lesser. So we can make EG equal to BE. So we can make BE and we'll say EH equal using proposition 3 that allows us to cut off from a longer a piece equal to a shorter. Now let's connect H and C. What we notice here, okay, let's keep track of what we've done. We've made this line equal to this line, right? We bisected that line, so those lines are equal. Notice we have here an intersection of two lines, and we know from Prop 15 that vertical angles are equal. So this angle here and this angle here, I won't name them, but they're equal. And this should suggest to us, look, now we've got two triangles, this triangle and this triangle. And in this triangle, let's look at this, I'll make this one green, and I'll make this triangle red, if that's not too confusing. And we can prove that those two triangles are equal to one another because they have a side equal to a side, side 1, the angle in between equal, and side 2 equal to side 2. And so that's side angle side. That's our proof for the equality of triangles. And it proves not only is the base equal to the base and the triangle to the triangle, but all the corresponding angles are equal. And what we really care about in this particular case is that this angle in green here, in this triangle, I'll color block it, is equal to this angle here. I'll color block that one. Those two angles are equal. But notice this red here is our exterior angle. And our red angle is obviously is larger than this green angle. The green angle is part of the red. And so the whole is always greater than the part. So this angle here, and I don't have a number for it here, let's give it a number 5. This angle here, angle 5, is equal to angle 2. But this exterior angle is greater than 5, therefore this exterior angle is greater than 2 because 5 and 2 are equal. Therefore, we have proven that angle ACD, our exterior angle, is greater than the angle at A. We can do the same thing either on the same diagram. It might be a little cleaner to do it on a different diagram here. We can prove that this exterior angle is likewise greater than the angle at B. So let's look at how that would look. Again, here's our exterior angle. We're going to prove that it's greater than angle 3. So like we did before, we're going to bisect this line, BC, into two equal portions. We'll call this, I guess we need a new letter here. We'll call it K. And we're going to connect AK and extend it. And then from KL, a longer line, we'll cut off a piece equal to a shorter line, so that AK is therefore equal to KM. We're going to connect M and C. Remember, we made these equal. Those are equal. And notice here we have vertical angles that are equal. And so this should immediately suggest to us we've got side 1 equal to side 1, and side 2 equal to side 2. And the angle contained between those equal. And therefore we have two equal triangles, just like we did up here. And so we have this triangle being equal to this triangle. And particularly, we want to look at angle 3 being equal to this angle here. So I'm going to color block this angle, and this is equal to this angle here, angle 3. Well, how does that help us? Well, we need to extend this way. And what we'll see here, we can kind of imagine this. Notice we have two lines intersecting here, and it's going to make our vertical angles equal. So this angle is going to be equal to its vertical angle, this. So this is just the same angle as this. And we know that this angle is the whole, and this little color block is the part. Therefore, this angle is greater than this green, which is equal to this. Therefore, this angle is greater than angle 3, and this angle is equal to this. Therefore, this exterior angle is greater than angle 3. And that's the second thing that we're meant to prove. Therefore, in a triangle, if one of the sides be produced, the exterior angle is larger than either of the opposite and interior angles. We conclude the proof with QED.